Hey guys, welcome to chapter 5.2, inverse and one-to-one functions. So first we're going to start with one-to-one functions. A one-to-one function is where you get a different output for each input, or a different range for each domain you input. So if I said, let's say here's x and here's y. If I put in 3, 4, 5, 6, I get 8, 9, 10, 11. This is one-to-one because each value of x is going to give me a value of y. And it's also a function. And so let's look at this example. If we had 3, 4, 5, 6, and then we had like 10, 10, 11, 11. None of the x's over here repeat, so it is still a function. These y's can repeat and still be a function. However, it is no longer a one-to-one function because this could go to this or this. So now it's no longer a one-to-one function. Just as for a function, we use the vertical line test. For a one-to-one function, we can use the horizontal line test. And so what this does is it checks for one-to-one because let's say you have a line. It passed the vertical line test, it is a function. It passed the horizontal line test. At each point along here, a horizontal line at any point is only going to touch one point on the line. So that is both a function and a one-to-one function. If we had a parabola, this is a function because it passes the vertical line test at each point. However, it is not a one-to-one function because a horizontal line would touch it at 2 points. So that's the easy way to see it. Algebraically, you can see that y equals x squared is not going to be a one-to-one function because I can put in two different values of x, 1 and -1, and I'm going to get the same y output. So you'd have 1, 1, and you'd get -1, 1. So if we look at it here, we have -1, and we have 1, and we get 1, 1. So this could go here or here. This could go here or here. So this is not one-to-one. However, if you take function y cubed, y equals x cubed, we can see graphically it's going to be both a function and a one-to-one function. And algebraically, if you plug in -1 cubed and 1 cubed, you're going to get -1, -1, and you're going to get 1, 1. You put it in a chart, XY chart. This has to go with this, this has to go with this. It's a one-to-one function. Next, we're going to talk about inverse functions. So the reason we just went over what a one-to-one function is because for an inverse function, for something to have an inverse function or to be an inverse function, it has to be a one-to-one. So if a function is a one-to-one, you can find the inverse function. Otherwise, you can't. And if you have an inverse function, you know it is also a one-to-one function. So the format for an inverse function, so here you have the function f of x. The inverse of f of x is going to be f, and then you're going to put the -1 right there. So that's an inverse function. To solve for an inverse function, all you do is you switch all x's for y's. So if I had the equation y equals x squared, the inverse of this is going to be, I'm going to switch the y to the x and the x to the y, and I'm going to solve for y. So then you could say y equals the square root of x. And so this would be rewritten as the inverse of f of x equals square root of x. Now if it gave you coordinates, like if it gave you 3, 5, and 2, 1, for example, these are two coordinates of f of x. If it asked you to find these coordinates for the inverse of f of x, all you use, you switch them. So 5, 3, and 1, 2. So graphically, f of x would be 1, 2, 3, 1, 2, 3, 4, 5, 3, 5, and then 2, 1, like this, would be your line. Your inverse function would be 1, 2, 3, 4, 5, 1, 2, 3, right here, and then 1, 2, right here. So those are inverse of each other. So let's say it gives you these coordinates here. So it gives you the coordinates for f of x. F of x consists of the points -3, -27, -2, -8, -1, -1. So the inverse coordinates, you just switch. Switch, switch. So -27, -3, -8, -2, -1, -1. If it asked you for the domain now of the inverse function, if the function consists of only points like this, then you would say that the domain of your inverse function is going to be -27, -8, and -1. I just picked all your x values here. The range of your inverse function is going to be all your y values, here, here, and here. So -3, -2, -1. Now, as you can probably tell from that last problem, we can say something, we can say a little rule or pattern about this. We can say that the domain of f of x is the range of the inverse. And then likewise, we can say the range of f of x equals the domain of the inverse. So this makes sense because you switch the coordinates, so obviously they're going to have opposite domains and ranges. So the next thing is commonly used to test for if a function is an inverse or not. So the rule to use this is the inverse of f of x. So that has to equal x. So -1 of f of x has to equal x, and then also f of the inverse has to equal x. So if you take the inverse of the function, you're just going to get x. You can think about it this like these cancel out and you just get left with x, which kind of makes sense by looking at it. But so let's do an example. If you had, let's say you have f of x equals x to the fifth. The inverse of that we can see, obviously to undo that you're going to do the fifth root of x. But say we want to test to see if these are truly inverse. We can do either or, but let's say we want to do this one. So just do it like a normal composite function. f-1, then plug in f of x, which is x to the fifth. And then everywhere you see x in your inverse function, you plug in x to the fifth. It would be the fifth root of x to the fifth, which equals x. So yes, these are inverse functions of each other. If you did this and you got x squared, 3x, x plus 2, anything, like you get something that's not x, then you can say these are not inverse of each other. So for inverse functions, there is some symmetry. They're going to be symmetrical with respect to the line y equals x. And this makes sense because you're completely flipping it. You're flipping the coordinates. So if you, I'm just going to make up some graph. If you had like, goes up and then down like this, if this is your f of x, let's plot the line, that's y equals x, then this one's going to be like this. It's going to be the exact opposite. It's going to be completely symmetrical along this line. So that's it for chapter 5.2. It's pretty straightforward, just getting into working with inverse functions, and now we're going to move on to a little bit more complicated functions such as exponential functions and then logarithmic functions. So it'll get a little harder, but that's the basic rundown for inverse functions. So we'll see you in the next video.